All right, yeah, worksheet dealt with piecewise graphs, uh, just a different type of function. Questions you have on anything with respect to piecewise graphs? Solutions were provided for you. Yeah. Number 3. So we have 3 different functions here. We have 3 different functions. We have x plus 2 when x is less than -2. We have the value 1 for when you're between 2 and -2 and 2. And when you're greater than or equal to 2, you have x minus 1. Okay, so we have 3 different graphs that we have to graph here. Y equals x plus 2 gives us a slope of 2, y-intercept of 1, or slope of 1, y-intercept of 2. So I go a dot, I can go up 1 to the right 1. We're looking at my graph. Here would be our graph. But we only want the values of x that are less than the value of 2 or -2, which would be an open dot on -2 going to the left. So I can shrink my graph down, maybe. Oh, bye. I can shrink my graph down to this. We have an arrow and we have an open dot there at -2. Y equals 1 is just going to be a horizontal line at y equals 1. So we have a horizontal line there, and we have to shrink that down to a solid dot on -2 and an open dot on +2. So we have to shrink our line down to that. So we have a solid dot here and an open dot here. And then the last one is y equals x minus 1, where we have a slope of 1, y-intercept of -1. So we have a dot here and a slope of 1. So my graph would be this. And we need to have a solid dot on 2 and going to the right. So what that will do is that will fill in this open dot that I have here and make this a solid dot. And then we have an arrow here. Okay, once again, it's one of those problems that will fill in the open dot like we had yesterday. Other questions? Yeah. I'm sorry, what? So the solutions weren't there. They were on the next day. Sorry about that. Just had to search. Right, today you will need your calculator, your graphing calculator. We'll be dealing with a lot of graphs. We'll still be working with graphs, but today we're going to work with the idea of translations. I'm not a huge fan of the translations, but it's something that's required in the curriculum, so we go through them. I always find as you advance yourself in mathematics, there are easier ways to go about doing things. I'm not always looking for a translation, but once again, it's a part of mathematics that exists in the graphs, and it's something they ask us to do. So sometimes you just put your head down and go forward. Just like at home, when your mom and dad ask you to do something and you don't quite agree with it, you just put your head down and go forward and get it done. So that's what we'll do today. What I want you to do in your Y1, I want you to type in, if you have a function here, you're going to have to clear it out of there. Make sure you zoom and you hit Z6. That standardizes your graph to negative 10, 10 on both the X and Y axis. What I want you to do in your Y1, type in your X squared. And your Y2, type in your X minus 1 quantity squared, and your Y3, X minus 2 quantity squared. And your X3, type in your X plus 2 quantity squared. So we're just typing in your X squared, then X minus 2 quantity squared, and then your X plus 2. Quantity squared. And go ahead and graph. Now what will happen is your Y1 will come up first, your Y2 will come up second, and your Y3 will come up third. Okay, so when you go to your graph, you'll get 3 graphs there. Here's your Y equals X squared. Here's your Y equals X minus 2 quantity squared. And then here's Y equals X plus 2 quantity squared. Now if we go back to your Y equals, go down to your Y3, go to your equal sign, and hit enter. What it does is unhighlight your equal sign. What that will do for you then, when we go to our graph, we'll just take a look at the first 2 graphs. Here's my first graph, and here's my second graph. They look the same, except for what has occurred to the second graph. What has occurred to y2? To the right, how many spaces? 2 spaces. So what has occurred is we have slid to the right. Our x squared got slid to the right 2 spaces. Now if we go to our y equals again and unhighlight the second one, equal sign, and then hit enter on the third equal sign. What it will do is that will just graph the second, the first and the third, and we hit enter. Oops. We hit graph. Here's our first graph. Here's our second graph. What has happened now to our graphs, Grayson? It's moved to the left 3 spaces. So it moved our x squared to the left 2 spaces. What this is called a horizontal translation. What we are doing with the horizontal translation is we are sliding a graph sliding the graph horizontally to the left and to the right. Now, if we take a look, when we have x minus 2, we are sliding to the right. When we have x plus 2, we are sliding to the left. So, when we have our base equation, we have our x squared minus our horizontal translation. Okay, we have our, we have our x squared minus our horizontal translation. So what is being subtracted from our x value? What is being subtracted from our x value is our horizontal translation. Very similar to when you were in trig class and we were talking about the horizontal phase shift. It was a slide of the graph to the left to the right. Okay, what is the value that's being subtracted from our variable? Now, if we take a look, we still have our y1 is x squared. In your y2 and your y3, type in your x squared minus 2 and your x squared plus 2. Go ahead and turn off your y3. And go ahead and graph. Once again, you get your x squared first. Then we have the x squared minus 2. With our graph now, what has happened to our x squared? What has happened to our x squared here? Move down 2 spaces. So when we subtract off the 2, okay, this is going to move down our graph of x squared, 2 spaces. Then if I turn off y2 and go to y3 and turn y3 on, hopefully you can by now figure out what's going to happen. Courtney, what's going to happen here? Up 2 spaces. So we're going to go up two spaces. This is called a vertical translation. It's a sliding up and down. Of a graph. A slide up and down of a graph. The vertical translation is the value that's being added or subtracted. So we have y equals our x squared plus our vertical translation. Okay, if I'm going down 2, I'm subtracting off 2. If I'm going up 2, I'm adding 2. So it's opposite to the horizontal translation, where we have a negative sign in there. Go ahead and just take y equals x squared plus 3 and x minus 2. I'm sorry, y equals x cubed and y equals x minus 2 cubed. Scrap those two. Make sure it's still doing the exact same thing. Do we still get the horizontal translation of 2? What we should see here is we should once again see a horizontal translation of 2 here. Okay, and we have x minus a negative 2 here. We should see a horizontal translation of 2 to the left here. Okay, once again, you have to do a little ching boom here. We have to undo the boom ching, x minus a negative 2. And we should see the same thing with our vertical translations of our graphs here. Now, if we take a look at absolute value, your calculator will graph your absolute value. Wants you to type in absolute value. Well, the question is, where do I find the absolute value at? So if we go y equals and we clear And we clear. We have to find our absolute value. If we hit the math button and go under NUM, okay, hit your math button. You have your option number one is the absolute value. So we have the absolute value of X in your Y1. And then go ahead and type in your Y2, your absolute value of X minus 2. So once again, hit your math button, hit your right arrow that takes you to NUM. Your absolute value is the second one, or the first one. Make sure you close your parenthesis out. And what you'll get is you'll get 2 V's for victory. And anytime you deal with an absolute value, you're going to get a V as a solution. But we still should see the same thing. We should still see a horizontal translation of 2. Once again, my main purpose in this is to show you that you can still graph absolute values and where your absolute value function is on your calculator. Because a lot of times we have our calculator and yeah, we get some, we can do the basic stuff with it, but finding the little things that are a little bit more additional that your calculator will do is the more difficult things. Your calculator will also graph circles. If we take a look at our circles here, here would be a circle with the center point at 0, 0, and a radius of 3. Going back to what we did with the circles, what would be our center point if we have x minus 2 quantity squared plus y minus 3 quantity squared? What would be our center point for this, Kylie? 2 and 3. So we have a center point at 2 and 3. We would still have a radius of a value of 3. So what is being subtracted from x, what is being subtracted from y, is just a horizontal and vertical translation. So if we take a look at our graph, the first point we have center point at 0, 0. We can go to the left, to the right, up and down 3. Let me get our Stewie head. The second one would go center point at 2, at center point at 2, 3. All we're doing is we're translating all of our points 2 to the left and 3 upwards. We can still go 3 points. We would get the exact same graph, the exact same Stewie head, but everything would be translated 2 to the right and 3 upwards. We can compress a graph. Okay, if we take a look at two functions here, okay, I want you to first type in y equals x squared in your y1. In your y2, type in your 2x squared. And go ahead and graph the functions. We get our first function, and when we go 2x squared, what happens is your graph starts to skinny out. Okay, it will skinny out. That's called a compression of the graph. If we type in your y2 0.5 x squared and graph that, what will happen is we get our x squared and we get a widening of our graph. The reason why that coefficient will make our y values bigger or smaller faster. So when you have this k value, the absolute value is greater than the value of 1. You're going to get a compression of the graph. It's going to get squeezed in because this value here, once again, is going to make my y value grow faster. So it's going to skinny out. When this k value is less than the value 1, the y value is not going to grow as fast, so it's going to widen out. It's going to fatten out some. So that's ways of being able to skinny out a graph or widen out a graph. So if I take a look, we have an equation for a base function of y equals x to the fourth with compression and a horizontal translation of -2 and a vertical translation of 5. Okay, write an equation. You have a base equation of x to the fourth. You want to have compression. You want a horizontal translation of -2 and a vertical translation of 5. And check your equation with somebody around you. With that compression factor, if you're skinnying it out or if you're compressing it, your k value just has to be greater than the value of 2 or greater than the value of 1. You can use any value that you want. I use 2 because it's easy. But if you use 3, you use 4, you use 5, that would be fine also. What would be an equation? You have your base equation of y equals x to the fourth. You want a horizontal translation of -2, vertical translation of 5, and you want it skinnied out. You want a compression. What would be an equation for that? we first take a look at just the horizontal translation, we have our quantity here. Inside the parentheses, what could we write inside the parentheses to take care of the horizontal translation? Emily? X plus 2. And that will be to the fourth power. Okay, what we have is we have x minus a negative 2, which will give us our x plus 2. Now to deal with the vertical translation, what are we going to do to the x plus 2 quantity to the fourth power, Cole, to deal with the vertical translation?
We're going to add 5.
Add 5. Now to deal with the compression of this, we have to get a coefficient to the x plus 2 to the fourth power. And we just need to make sure this coefficient is greater than 1. So you can use 2, you can use 3, you can use 1.5, you can use 1.1, just so it's greater than the value of 1. When we have reflection about the x-axis, when we have reflection about the x-axis, we substitute f of x, we put negative f of x in for f of x. Or we have negative y in for y. When we have reflection about the y-axis, we substitute negative x in for x. This is something that you do at the very end of the problem. So if you have a bunch of information here, you take care of the translations first. You take care of all that stuff first before you go into your reflection. You take your equation and you slide it and you translate it to where you need to translate it. Then, if I have a reflection about the x-axis, we sub in negative y for y. So if I take a look at this, we're going to just sub in negative y is equal to 2x plus 2 to the fourth plus the value of 5. Now to solve for y, we can multiply both sides by negative 1. So we have y is equal to negative 2, x plus 2 to the fourth minus the value of 5. But you do this after you do all your translations. Okay, don't try to throw the reflections in as you're doing the translation. Because first what you have to do is you have to translate the graph. You have to translate the graph to wherever it needs to move to. Then at that point, you can do a reflection about the x-axis or y-axis. If we take a look at this and reflecting about the y-axis, we sub negative x in for x. Oopsie. We substitute our negative x in for x. So we have negative x plus 2, or we can turn that around to go 2 minus x to the fourth power. But once again, we do this substitution after we do our translations. So do all your translations first, and then worry about if you have any reflections about the x and y axis. Okay, in your homework, you have a base equation of y equals x cubed. Okay, y equals x cubed. You're using that as your base equation. From that point, you have a bunch of different things. Just starts out with some easier ones, and then gets a little bit more as it builds as you go throughout the problems here. Questions you have? The last 5 minutes are yours.